So, okay, 3 carbon sugar, it is called triose. And then 4 carbon sugar, tetrose. But we seldom talk about this. As I mentioned last time in the last slides, we will mainly focus on hexose, 6 carbon sugar. Oh, we will also talk about pentose too. Pentose, the reason is that we will see pentose in DNA. In DNA and also RNA. Okay. So sugar nomenclature, I already told you that as soon as you see the suffix OSE, then it is mostly sugar. It gives you example here: sucrose, fructose, lactose, galactose, glucose. They all end with OSE. So OSE means sugar. As I told you, you have to memorize C6H12O6 because it is the formula for glucose. And yes, there are different ways to represent it. Some school, they require students to memorize this structure because the professor will ask them to write out the structure of glucose in the exam. But for me, well, I won't test you to draw out the structure of glucose because many of you take this class for general education requirement, for GE requirement, so you do not have to memorize the structure of the glucose. But one thing I want to highlight is that scientists, we are lazy, okay? We usually omit the carbon atoms so that when we draw it out, we don't see any carbon here. And also we like to number the carbon atom. So this is number 1, carbon 2, carbon 3, carbon 4, so on and so forth. And we number the carbon so that when we talk about, so that people will know which carbon atom we're talking about. And scientists are lazy. We like to omit the carbon when we draw out the structure, and sometimes we will even omit the hydrogen atom and hydroxide group, and also the CH2OH, because many of the scientists know that okay, this is a glucose, and they assume that okay, they know the structure of glucose. That's why they're too lazy to draw all the details atoms. So where can you find fructose? Well, of course, fructose, the word fruit, remind you of the actual fruit, like strawberry in this example here. Glucose, you can find it from your blood. This device here is to help you to monitor your blood glucose level. In case for people who have diabetes, they have to do this all the time. For pregnant women, if they have something called gestational diabetes, they also have to monitor their blood sugar level many times a day. And usually for women who have gestational diabetes, doctors will suggest the women to eat small meal but multiple times a day in order to control their blood sugar level. Usually for pregnant women, doctor will not prescribe any medication for the pregnant women because doctors don't want to affect the fetus. They will just tell them to monitor their blood glucose level and suggest them to, well, actually not suggest, they tell them to eat multiple small meals a day. Last but not least, galactose. Ga means half. So it's a half lactose molecules. Of course, we can find from the milk. Okay, let's take a look at the example of monosaccharides. They are all hexose. See, that's why I told you to memorize C6H12O6. Fructose. It is a 6-carbon molecule, but you say, but it looks like a pentagon. It is 6 carbon. Let's count the carbon. 1, 2, 3, 4, 5, and 6. It is a 6-carbon sugar. It has the same molecule as, it has the same formula as C6H12O6, but it's just arranged differently. And it looks like a pentagon. But it is, we still call it hexose, because the word hexose means of 6-carbon sugar. Now, glucose. Of course, we said that glucose is C6H12O6. Again, it has 6 carbon. Well, we start with here. This is number 1. And then carbon number 2, carbon number 3, carbon number 4, carbon number 5, carbon number 6. So, last but not least, galactose. Galactose is very similar to glucose. Carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5. You see that the only differences is this hydroxyl group here. Galactose is pointing upward, glucose is pointing downward. So let's take a look at some other stuff. So isomers, different molecules with the same number of kind of atoms. Some textbook calls stereoisomers. Stereoisomers. So the definition is that they are different molecules but with the same number of atoms. So they, for example, both glucose and fructose, they have the same equation, C6H12O6, but they are arranged differently. When they are arranged differently, then they have different structure. Remember, glucose is a hexose. Well, they're all hexose, but it looks like a hexagon. But a fructose is a pentagon. But even though it is a pentagon, we still call it hexose. And then we have something called a geometric isomer. Geometric isomer meaning that we have two types, cis and trans. What is cis and trans? Okay. For this one, you see that the hydroxyl group, they're on the same side, and the hydrogen group, they are also on the same side. We call this molecule a cis. CIS. This molecule is in a cis configuration because they are all the hydroxyl group and the hydrogen atom, they are on the same side. On the other hand, for this one, you can see that the hydrogen atom, they are diagonal. And the hydroxyl group, they are also diagonal. We call this trans. Cis-trans. So this is what we call geometrical isomers. Folks, if you work in a hospital, you have you will know that in hospital, especially in the emergency room, they have a lot of bag. One type is the saline bag, the other type is called dextrose. Well, before we talk about dextrose, let's talk about the mirror image isomers first. So if you put a molecule in front of a mirror like here, then you'll get a mirror image of the molecule. So the mirror image, they usually have special properties. For example, if you pass the light going through let's say one a group of molecule here, then let's say, for example, when the light go through this molecule, somehow this molecule has the properties this molecule is able to rotate the sunlight, let's say, to the right hand side. If this molecule is able to rotate the sunlight into the right hand side, then we call it D type. D is like the right hand side, but if let's say the other one, the one that's circled by blue, the mirror image that can rotate the sunlight into left hand side, we call it L type. And glucose, believe it or not, they also have a D glucose and L glucose. Yes, if you have a lot of D glucose molecule, then when sunlight pass through the D glucose molecule, the sunlight will be rotated to the right hand side, and then if you pass the sunlight going through the L glucose, then the sunlight will be rotated into the left hand side. So the D glucose in the hospital, we call it dextrose. And OSC again means sugar. D, dex, basically imply that it is the D, which will turn the sunlight to the right hand side. Then this is called dextrose. In other words, the glucose that we use in our body, they are all D glucose or dextrose. Mirror image isomer of glucose. Okay, see, I told you that D glucose and L glucose. D glucose is so this is the mirror image, and D glucose is the naturally occurring one. That's why we have a lot more D glucose in our body. And simple carbohydrate, pentose. Okay, as I mentioned before, we also need to learn about pentose, because we use pentose in DNA and RNA. Remember, I drew this on the previous slices. Then we have deoxyribose. What does it mean, deoxyribose? That means in one of the atom attached to the carbon, the second carbon, I'll say the second carbon 2 here, carbon 2, it is a hydrogen. It lacks an oxygen. If we compare it to the ribose, you see that this one here attached to the carbon 2, the second carbon atom here, it is a hydroxyl group, OH. It has an oxygen. That's why we call this deoxy. D means remove. Oxy. Oops. Oxy means oxygen, of course. So deoxyribose, meaning that it is a pentose sugar that has one oxygen atom being removed. So it's deoxyribose is a pentose sugar with one oxygen atom removed, which is attached to the carbon number 2. Therefore, we call it DNA, deoxyribose nucleic acid. And RNA stands for ribose nucleic acid.